Hi, everyone. Welcome to our third online meeting. Just want to check in and make sure that you can hear me and you can see the PowerPoint deck that I have shown on the screen. If a few of you could just give me a yes in the text chat, that would be great. Thanks. Hi, everyone. Great to see you. Love the participation. Okay, so I want you to promise me to keep up this level of participation for like at least the next hour, maybe hour and a half. It's gonna be helpful as we go through some of the exercises for today. So I just like to, as always, start out with the agenda for today, and it's always really the same agenda. We're just covering different topics. And so this is really a workshop format. Want to make sure that you're successfully developing your knowledge and skills in R, give you an opportunity to practice, and also to answer your questions. So right now, all of you should have your mics muted, but also if you do have questions, you can feel free to use your mic and kind of speak up. And in addition, the text chat throughout. I'll try to monitor that. Also, I have to really commend this class. This class of MSBA students has been so active on the discussion forum, and I hope that you find that a helpful way to kind of ask questions of both myself and Ray, our teaching fellow. For me, just to tell you, it's been really fun to kind of respond. I know that like I'm helping you, maybe solve the problem or think about it a little bit differently, and also to observe you answering questions of others. So that was fantastic. Feel free to continue using discussion forums, but also these sessions are great for questions as well. So why don't I start? Why don't I open the floor if there are questions? Great. So I got a question in a private chat about what my intent is regarding memorization of functions versus just kind of knowing how to employ the functions. And so, look, it's knowing what the functions do is the most important thing, and knowing where to find information when you don't know how to solve problems is important. And so a lot of the exercises that I give you are somewhat repetitive. When I ask you to import the data, view the data, right? If you guys remember that for many of the exercises, and even the ones that we do here together, and that's just to give you extra practice. And so knowing that when you have data that's in CSV format, that you just import, you use the readr library and you use the readr function to import that data. And if you wanted to take a look at how many rows and columns there are, that you use a dim function, but to kind of repeat those. That's really it's the practice that will develop the habit, and it won't be that you're memorizing it, it will be that you know it. So I believe in kind of knowing it versus memorizing it. And we know it by doing it through guided practice and then practice on your own. Hope that answers the question. Cool. Are there any other questions? Okay, as always, throughout, feel free to raise any questions you might have. But I appreciate that question that came up. What are the things that we did in session 2? And depending on the level of questions from each of the sessions, you might have been in a different one. But we talked a little bit about R Markdown. So does anybody have any questions about R Markdown? Like maybe I could just ask you a question like, are you familiar with R Markdown? Just give me a yes or no, a Y or N in the text chat. Some people are no, no, no. Okay, all right. A little bit, some no's, some yeses. Okay, so that means that we're all at different. We're not at the same page yet, and that's fine. So we've moved from session 1, writing our code in the console window, right? So we're using R as a calculator. Second, we moved to writing our own scripts, and these were called R scripts. And now third, we're going to kind of progress in writing our code and think about using R to help us analyze and present data and our findings. And we can do that really nicely in what's called an R Markdown document. So we're moving to a file type called RMD, literally a file type of what your program is called. And so we're going to be kind of from now on in writing our code as a markdown. The nice thing here is that you're able to write some text in English, like what you're trying to do. Like let's pretend that you downloaded a data set that has data on bike sharing data. Okay, and that bike sharing data is pretty interesting. It tells you like how many bikes are rented per day for a 2-year period. And you import that data set and you want to kind of learn a little bit about it. So you run some summary statistics and you can present those. So you could simply in English write out your goal, just be like, okay, analyzing data using the summary statistics and found, colon, and then you can have your data be presented based on the code that you write. And let's say that you want to visualize some of that data, like a time series graph or a line chart that shows the change in the number of rentals over some time period. Okay, so it allows us to mix in things that we'd write for like a report or for a blog post or for a website into a special kind of document, and it's called an RMD. So you'll see step 2, it says write content with the easy to use R Markdown syntax, which we'll go over a little bit. And then we can embed our code into our report. It's pretty cool. And then that can be dynamic. So every time we run the report, if the data changes, the output would change. We can also then, in step 4, render that report, which basically means convert it to a format that we want to convert it to, which would be let's say a PDF document or a Microsoft Word document, even like a PowerPoint type presentation or an HTML file. And all the materials that I created for this class that you're reading are all markdown files. So you should be really familiar with how that looks. So you're able to read about, like, if you go to chapter 5, you're able to read about statistical visualizations, see some of the code, and then see the visualization presented, which is the output of the code. So you're able to see 3 things really nicely and have it really nicely formatted. So that's just a general of Markdown. So we're going to move into that when we start the exercises. But I also want to move on to our topic, which is our topic for this session, is graphs in R. Now, I think that you're pretty lucky because you get to have a whole class in data visualization in Module 3 in Shanghai that I will be teaching. But, oops, I'm hearing a little feedback. I'm going to just make sure everybody's muted because I'm just hearing some feedback. So graphs in R are, I want to just bring up some basic points on that, and then we will build on this foundational knowledge in Module 3 for sure, but I want to give you some basic points so you can begin creating visualizations right away. You don't have to wait till Module 3. So first up, when we create visualizations, we're doing it with a purpose and for a reason. Part of it might be that you're learning how to create visualizations in R, just learning the technique of it. But once you get beyond the technique, the idea is to create visualizations that help you understand your data. And that's when you use visualization for what we call exploratory analysis. But visualization is also used for presentation. So to be able to share insights with others that you've mined or analyzed from the data and present it in a way almost using the data graphic that you create as evidence of your insight. So instead of showing somebody a table of numbers and saying there's a correlation between these 2 variables, you show a nice scatter plot that shows the correlation, and you make that evidence really visible, literally to your users. And so visualization is again, it's not just a technique, but it's that added 20% that you really need to add to any data project that you're doing. And that's why there's a focus on it in this program. And so it's not only for, that exploration process, and usually the exploration might be where you're just like visualizing, clusters of data, or visualizing, trends or things like that, something that you may not want others to see for your own eyes. But when it's for somebody else's eyes, this is where we take a lot of care in showing how we present our data. We need to make sure that a lot of things are clear to our users. Does anybody want to like share or comment on what things would be important for you to communicate to users when showing them a data graphic? Great. Yeah, thanks for the comments on that. This is wonderful. So somebody said the data source. I thought that was great. Where did this data come from? Right. So you need to make sure that you're holding up most to the highest integrity with the use of data, and that you also have permission to use that data that you're visualizing. Another thing would be that you label your axes clearly. So I saw that, and some people said trends or patterns, prediction. Well, that there is an insight there. Not every graph's going to show a trend. Not every graph's going to show a prediction. And so you want to make sure that the insight, whatever category it falls in, might be a historical trend. It might be a future prediction. Right? It might be a current description of what's happening now, like I don't know, a graph of the United States or the world that shows, the number of Twitter users online at this very moment. Okay, so something that's very meant to be about the present. And then I see so Janya talking about colors for understanding, right? So our aesthetic elements have to be used purposefully, and we're gonna go over a few of those aesthetic elements today. But what would be, aside from color, what are other, what we call aesthetic elements that we should use purposefully? Font size, spacing, contrast, density, maybe that's to Anne's comment. Correct chart type. So we're going to use a chart type that's appropriate for our data. This is terrific. So you already have such a strong foundation and instinct in those things that are important for visualization. So now it's about how do we then apply that, right? So then now we're getting back to the technique. So today I'm going to show you some techniques. And then we'll go back to making sure that those techniques are appropriate for our objective. That's why we get a whole class on that. There are several packages in R, in particular, that allow you to visualize data. Some of these are listed here. We have the basic graphics package. We'll start using that. Excuse me. Then we have the lattice package that allows us to create some interesting graphics: ggplot2, ggthemes, and ggviz. There are many, many more. Okay, there's a package called maps, for instance, that allow us to actually show geospatial visualizations. And there are even more advanced type of packages like Shiny, for instance, that allow us to visualize data that's interactive. Another one would be Plotly. So these two packages, I'll write them in the text chat, Shiny and Plotly, are contenders for allowing us to, for contenders or that we can use to create charts and graphs. And many of them build on some of the knowledge that we'll develop when we learn about ggplot2 in particular. Okay, any questions on this piece? All right, good. All right, so now when we learn technique, we're not going to learn the most sophisticated technique at once. And so this is where I'm going to ask for your patience. We're going to start by using a function called plot. Okay, good old plot. Plot comes from a package called graphics. Okay, and here is just a really simple example of a plot that we're going to create, actually, using the movies data set. And the movies data set is available in exercise 5.1. So you can go ahead and download it if you haven't already. And here we're creating a certain type of plot. Can anybody guess what kind of plot we're creating here? So here we're creating a scatter plot. And how do I know that? So when we use the plot function and we pass in two numeric continuous variables like x and y, chances are it's going to yield a scatter plot. Okay, we can Ali, great. We can specify the type of plot we want, and we'll learn how to do that together. Okay. I don't want to just tell you, I want you to understand how you can make that selection, where you find that information, okay? So here is our basic, and yes it is. So here we have X and Y, those are the parameters that we pass in, okay? That's gonna be our data. So it might be like, movie, tickets sold as our X variable, and then movie $sign, gross sales, okay? The next parameter, main, does anybody know what main is? Main equals, and it's a string. Yeah, it's the title of the chart. How about X lab? What does that represent? Yeah, that's the X-axis label, okay? And you can guess what Y lab is, right? So Y lab is your Y-axis label. How about frame plot equals false? Omer, yeah. We're going to get rid of the border that, I don't know if you've seen charts that have been created in R, some of the basic ones, but a lot of them come with like these borders around them. And as I was mentioning earlier, we focus a lot on the aesthetic elements to ensure that they really add to the message, not hinder it. And so when we put a box around a chart, it really adds no information. So we tend to remove that box for aesthetic reasons. So frame plot equals false. Okay, and what's COL? Anybody know what that means? Yeah, and it's color, and this is the hexadecimal code for, you might have noticed, one of my favorite colors. And so this is the signature color that I use in all my materials for my data visualization book and also all the data graphics that I use. So I branded just like the, Time Magazine or The Economist or Wall Street Journal. They all have a certain aesthetic. It's not exactly aqua, Sujana. It's actually called modern cyan. And I just say you pick a color that you like, and then you figure out what that hexadecimal code is, rather than trying to figure out the hexadecimal code for a color that you're kind of imagining in your brain. And you could use tools like Photoshop and others to figure out the hexadecimal code. There are many other, there are a few that I'll introduce you to. Oh, thanks, Anne. Yeah, that's a great site. So if you want to make your, well, let me back up for a second. Excuse me. Because I pass in this COL parameter, what am I doing? What's going to be modern cyan? What is that color, where is that color going to be applied in my plot? Besides the plot, the data points. Yeah, the color of those points of my scatter plot. Okay, that's what this color parameter does. So we know that without even seeing it, this is a great exercise. I want you to understand kind of what's happening, and then you'll get the magic of it produced. And in this particular case, we've This is a very simple function. And if you haven't noticed, some of the plots, especially just using this basic plot function in R, tend to look like they came out of like 1983, right? They're like a little bit rustic looking, they're a little pixelated. So the graphics package isn't a very strong package for producing, say, publication ready images. And we'll start using other packages to like ggplot2 to make charts that are a little bit more aesthetically pleasing. But in any case, we start with the foundation because you may need to use plot to plot data that for one reason or another. So let's begin with one other. I'm sorry. I wanted to move you to another slide where I will show a comparison of this function that creates a scatter plot with another package called ggplot2. And we can also create plots using this. And I'm going to just show you a few slides on this basic structure. And at the end of today's lesson, we'll get to building a ggplot. What's the difference? We're just talking about using different packages to visualize data. ggplot2, that package is one that's really like, the industry standard in R, what everyone uses to visualize data, in addition to those other ones. So again, this is all about learning the technique of visualization and the wide toolkit. Okay, so now I'm going to give you 2 tools today, maybe 3, maybe 4. And the tools I'm talking about tools like the plot function, the box. I'm typing this in the text chat. The box plot function. Okay, maybe a function called scatter plot, and then another one called ggplot. And so just stay with me on it, and I'm going to explain all of this, okay? So with ggplot, it looks a lot different in terms of how you pass in data and how you define your chart type. So I just showed you the plot function, and now this is a different function. So anytime we use something called ggplot, we are passing in the data frame we're working with, and we identify, for instance, using this AES function, the X and Y variables. This happens every time you create any kind of plot using the ggplot function. Then you define your chart type by using this plus sign and this geom underscore chart type, whatever the chart type is going to be. So we're going to anything in green is data that you change, okay? And then we can add other functions to this ggplot function call. So let me walk you through a few. So this would be if we wanted to create a density plot. Okay, so this would look like if you wanted to create a normal curve, for instance, this would be a density. So we would use geom equals density, and we're only using one variable. Because if I'm showing a distribution, I'm showing a distribution of one variable. If I wanted to do a bar chart, pass in my data, pass in my X, pass in my Y, and choose geom underscore bar. If I wanted to do a box plot, I could do it this way. For a box plot, you would have just one variable. This is an error. If you had a line chart, you would have one variable for your x-axis, one for your y, and then you could add geom line. And it keeps going. For instance, this is your density plot, and that's the syntax for the density plot. I'm going to show this quickly, but just to give you a sense of how it relates. So you can see that you have your data, you have your single variable, and then you have you're making that call to geom underscore density. And then you can add labels like a title, a subtitle, a caption, and you can. So learning this package is quite complex. because then you have to learn how to fill the graph and how to apply different themes to it, how to maybe customize the font, how to remove some of the chart junk, how to format the scale so it's continuous. I don't know if you noticed before, but if you look at the x-axis scale here, there's no commas. It just says 2,500, 5,000, 7,500. Go to the next slide. Now I have commas because I've added an additional function to ggplot for that kind of customization. Same with histograms. We have a lot of functions that we can manipulate when it comes to histogram. But this is the basic structure. But we could, and this is the basic output that comes in R. So we work really hard to go from this to something that looks like this last one. Okay, so, and that takes, 5 or 6 steps, and understanding what the functions do and how we can manipulate our data. Here's just another example of a bar chart. And this is the basic output of a bar chart. And then we work to then, customize it. So I like to show these slides more as inspiration. We'll master this when it comes to the data viz course, but you can start using the ggplot function as well. And so I hope that we'll have time to go over that today. I'm sure we will. So any questions on this? General questions before we get to trying all this out? Yeah, good questions. Yes, so we are using a variety of functions to create graphs, and one of those is histogram, HIS. There's also a function called histogram to answer that, because the question came up, well, we're using HIST, the histogram function, to create a histogram, but you kind of showed us how to just do a ggplot. So again, there's multiple ways to do this. The second question was, is there a difference between ggplot and ggplot2? The name of the library is called ggplot2. The name of the function is called ggplot. Riza, that's probably why you're seeing that it's not available for your version of R. You need ggplot2. Yogesh asked a question, is the data phys class going to use R or more Tableau? I'm going to ask you, Yogesh, what do you want? You want more R or you want Tableau? Or you want both? Yeah, both. All right, we'll do both. That sounds great. And believe it or not, you can actually use R and Tableau together. So the learning really never stops, and that's kind of understanding where you are in your own learning and where you want to go is important with this stuff, because there's so much to learn, but you might not care about modifying aesthetics on a chart, but knowing that you can do it, you can hire somebody else to help you to do that. Robert, I either use require or I use library ggplot2. Either one would be fine. Good question. So we're going to start with exercise 5.1. So just want to make sure I'm showing it on the screen now, but I can't tell if you can see it or not. So let me know if you can see my screen. Yeah, you can see it. Thank you. So we're going to be using the movies data set, movies.csv. And what I want you to do is I want you to work on questions 1 through 4 on your own. I'm going to give you 10 minutes. If you get done with those questions, finish the exercise, because then I want to ask you how you achieved your goals doing this. So first, let's go over what I want you to do. Like every exercise, we get to know our data by importing it, and we know we use the readr function to do that. We view our data, so we can do that by typing in the name of our data frame or using the view command. We can look at the column names, look at the dimensions using the dim function. That should start becoming, like a habit to you. The second step is the scatter plots. So I want you to use the plot function first, okay, to build a scatter plot. I kind of gave you a template. I said, use the plot function, pass in X and Y. So in this example, you're gonna have to figure out what X and Y are. And then I'm gonna ask you to redo the scatter plot. So I want you to do A, B, C, and D by adjusting the scales. You'll notice when you first create the scatter plot, the scale, what's listed as the scale for the x-axis and y will be unreadable, okay? There'll be numbers too big to print. So what you need to do is to kind of normalize the scale. So I'm just going to have you do that by simple dividing by either by 1,000, then 100,000, then by 1,000,000. And then I'm going to ask you about the correlation between these two. So I want you to use the COR function. Finally, in part 4, I'm going to ask you to create a scatter plot with a line. So I want you to build a chart that has a scatter plot, the same one that you did in number 2, but also plot it with a line. Okay, and that line should really be like a regression line. And how we do that is we need to go to the R console window, type in plot, like I am right now in the text chat, and then read the documentation on the plot function. And see if there's a parameter that's available that lets us plot both points and lines on a single plot. Okay, so that's that. So there's a little bit of a research exercise there looking at documentation, and then I want you to build it. I want you to build it using the normalized data on the million scale. So what you did, exactly the code that you did in part D, I want you to do in A, 4A, and then I want you to make sure that when you build your plot, it has a label for the x-axis and y-axis and a plot title label. And then the rest, you can continue on your own if 10 minutes was too much time just for 1 through 4. I want you to then continue with the rest of the exercises, and then I will go through everything together, and then we'll do an exercise where we use ggplot2. So any questions before I put the timer on, the 10-minute timer? Okay, so it's 7:05 p.m. Eastern Standard Time, so I'll give you until 7:15. Okay, so it's been about 10 minutes. I'd like us all to rejoin as a class, and I want to go over the first couple questions that we discussed. So right now I'm showing my R screen. So if you're not seeing it, let me know, or give me a yes if, just tell me if you can see my R screen. Okay, thanks. Just like to double check that. And we're going to start by, thank you, by creating an R Markdown document. File, new file, R Markdown. We give it a title, exercise 5, demonstration part 2, because I gave one earlier today, okay? And then you could choose your format that you want eventually to be the output format. So we mentioned that, we have a variety of output formats in our Markdown. We'll choose HTML because that's going to be the most common, and we'll say okay. And then we get sample Markdown document. Has a lot of stuff we're not going to use, but it includes some things I want to talk about. So first, it has these different descriptors for title, author, date, and output. Really simple stuff, everything that you kind of just filled in that window that popped up, okay? What does this mean? R setup, comma, include false. Does anybody know? So what's happening here is this is required on lines 1 through 6, okay, for an R Markdown document. Then after that, I can type anything I want on multiple lines, okay? Then anytime I want to include some R code, I could say insert R, right? I went to this little insert menu, insert R. And I could say something like print, okay? And here, I could just, if I want to just execute this little chunk, I can press play here and it prints out. It executes whatever I have in here in R, okay? Now, the default piece of R code, or the R chunk it's called, said it's just naming what this chunk is called. And you'll see all the way down at the bottom here, it says chunk 2 : setup. So every chunk, this is chunk 1, this is chunk 2, is given a number. And if you give it a name here, it will be given a name like setup. So if I said R tulips, guess what? That's the name of my chunk. That's all that word setup means. It sounds like it's supposed to be special. Okay. So tulips and setup. And if I want to include false, that means that I don't want to include this code when it outputs to HTML. Okay. In addition, the second line is saying when I run this as a knit-r, when I'm using this knit-r, it's referencing the knit-r package. And that means this button that I press when I want to publish this as an HTML file. So first it needs to generate the HTML file, and that's what this knit button will do. And then it's saying that my code chunks, right, tulips, setup, etc., for all of them, it's saying set it to true, echo equals true. That means that anything that you write in your R Markdown document, the code will show up in addition to the output. So here, look at tulips, code, output. So I'm gonna just cut and paste this piece, and if I wanted to say like this is exercise 1, and then I have my R code here. Okay. Everything else are just examples of. So you could delete everything else that's in the rest of the file. You could read it at some other time, but the idea is that for every, so you could say like question 1, it's like read in the data. And so how would I read in the data for my movies data set? You could just type. So reading in the data, we're not going to do this. We'll use the read underscore CSV. So that means we have to use the library, read R. Then we have to use movies and exactly. I'm not going to type everything we need to do by hand because there's a lot. As you know, when you start doing graphics, so much typing, right? Especially if you want to get those labels correctly. And then, okay, so there's our basic reading in our data. And so that would be question one. If you wanted to execute this, first I want to save my R Markdown document. Because if it's not saved in the place where movies.csv is saved, I'm going to have a problem, right? Unless I set my working directory correctly. So I'm going to say File, Save As. And I know that my movies CSV is stored in this folder. So I'm going to say exercise 05 demo 2. And Anne, I'm going to get to your question, but give me a little time with it because I want to kind of show you the value. So we're going to import our data, and then there we get our data imported. Wonderful. Now I'm assuming that you've all explored the data and done that, but that includes using the dim function. And so let's say I wanted to explore my data. I could write on line 21, explore the data. So you're really giving a description of what you're doing. Insert R, my R chunk. Look at my R chunk. These are backticks here. These aren't single quotes, they're backticks. This character exists right to the left of the number 1 button. It's a special way that we can have R code in line in an R Markdown document. Here I'll just say something like dim movies. All right, and then I could press this run button here. Okay? Now, can I run all of this at one time? Absolutely. So when I run all this at one time, I could just say, I could press this run button here and run all. Now my whole script will be, will run. And we're showing input and output in one R Markdown file. Okay. Let's say that I want to publish this to the web and create a report from this. Let's think about what's going to happen. Well, we've already set our output to an HTML document. Wonderful. This is going to be written there. This line, this area, this code chunk called setup will not be printed out because we said include equals false. So this chunk won't be in our report, but question 1 will be, and the code, and then explore the data and the output, and then this phrase explore the data, and then this R code and the output. So how do we test that or produce that HTML document? We use this knit button. Okay, so this should be expected output. You should expect this based on how I described what was going to happen. Now I've proved to you kind of what this does. I said type here, and you get this nice format. You can open this page in a web browser, and right now I'm showing the document that was produced, so let me know if you can't see it. And I'm also showing the input, library read underscore CSV, and then I see the output of the reading in the file, and then I see my command to show the dimensions, and then I see the output of that. Okay? I could, go one step further, open this in a web browser, and then you could see that it lives on my desktop. And now I have an HTML file on my desktop with my R code. I can go ahead and publish this to the web and do anything I want with it. Let's go back to, I just want to make sure, I'm going to turn off my screen sharing for 1 second. Go back and show my screen. So I'm showing my main screen. So we're looking right now at this demo markdown file. Okay, but we want to get back to exercise 5.1. So exercise 5.1, I want you to create this as a markdown document. So you might have started as a script or whatever, that's fine. Now you know that you just need to say file, new file, R, markdown, okay? The nice thing here is now you have an environment to work where you can see input and output within the same document. It works like what they call notebooks in Python, which you might have been working on in Panos' class. So did anybody get an answer to the first question? I mean, the second one, excuse me. We've already gotten to know our data. So this is my code of how I answered the first one, just so you can kind of see. But we've gone over this a lot, right? So reading in our file using the CSV function, I could look at how many variables are in the data frame. I could look at the names of the columns. I can look at more information about those variables, and I could see how many rows and columns there are. But if I want you to build your scatter plot now. Does anybody want to share their code? Or since I gave you time to work on it, please share your code that you've used to kind of create your scatter plot. Oh, I like people are picking different colors. Awesome. So what the first part A, 2A, is to use the simple graphics package, okay, and do a plot of X being the tickets sold and Y being gross sales. For part A, you might have gotten something like this, right? Where the X and Y variables scaling is just too difficult to read. Okay, so line 50 is the output that you see here. Then I ask you to redo the scatter plot, adjusting the scales. So I'm looking at how people have done that, and it looks like, okay, so to adjust the scales, let's just look at line 55, and I'll run that to see the output. So now I've divided tickets sold and gross sales by 1,000. It's a little bit more readable, right? Notice how my variable names for my X and Y labels are just literally the variable names. So we're going to work to change those pretty soon. Then I've asked you to redo the scatter plot by adjusting the scales by dividing by 100,000. It's becoming a lot more readable now. It's cool because we can see that outlier here too, right? Now let's do it one more time and divide by 1,000,000. And that's line 67 I'm showing you here. Again, I'm just showing you the simple use of the plot function, plotting in X and Y. Now I've got my scaling right. Now this is where you want to put the time in to like format your chart. Okay, adding a label, adding an X label, a Y label, a title, maybe changing the color. Okay, and in this refinement stage, I usually, if I'm going to use these variables a lot that I'm normalizing by dividing by uh, a 1,000,000, I'm going to store them in variables. Can anybody explain what's happening in line 72? Great. So we learned this from the last class. So we're just creating a new column in our movies data frame. Okay, and then I can reference this as my X and my Y parameters. So in this plot, I passed in my newly created variables, and I've given a nice title. I've added a X label and a Y label, and set the frame plot to false. We want to get rid of that box around it, and I've set my color of my points to modern cyan. I'm going to go ahead and run this code chunk. Okay, so you should see that. It looks a lot better than the previous one, obviously, and now things are labeled appropriately. I'm saying ticket sales in millions of USD, number of tickets sold in millions. Then I ask about what the correlation is. Does anybody have an answer to that? Number 3, what is the correlation between tickets sold and sales? So we could use the core function, and you should have gotten 1, right? It's a perfect correlation. I use this example a lot because I want you to it's obvious, and I want the expected output to be obvious right now. Okay, so when we're learning a technique, it's really hard to learn technique and interpretation like at the same time because we're so concerned about getting our code to work and everything. So, right. So 1 represents a perfect correlation. Anything negative would represent a negative correlation, and and then in between, you have to interpret what that value is, like the R-squared value, if it represents a significant enough of correlation or not. Closer to 1 is better. Okay. So the next one was to add a regression line as well. Can anybody share their code on how they did that? I'm scrolling through the text chat too to see if anybody added that in. Oh, so use the scatter plot function, Noah. That's great. We'll get to that one. But just using the good old plot function for now. So what you can do is look at the documentation. And so, Yogesh, awesome. So you use type equals both. And let's look at the code is everything is the same except we're adding this parameter is type equals B, which means both points and lines and a line. Now, how do I know that? Well, if I typed in at the command prompt here, question mark, if I typed in question mark plot, that would bring up my documentation on the right-hand side of the screen. Let me move that over for you. And here, scrolling up, I can see that the plot function comes from the graphic package. I see that it's generic XY plotting. It gives me a general description of what this function does. And I can see the arguments it takes. Well, we know good old X and Y. But this other argument's pretty cool, type. So P is for points, which is the default one. L is for lines. And if you wanted both points and lines, you use type equals B. Okay, and then there's many others. And then you see that we can use main for the main title. If you wanted a subtitle, you could use sub, X label, Y label, and more options. So let me bring back my screen so it's kind of visible for you. And we'll look at this code here where I show you how I did that. Okay, so now I'm getting that 45-degree line showing me that perfect correlation. And so the question for you is, say this data wasn't perfectly correlated, X and Y wasn't perfect. How would the line change? Two good answers. So use the best fit. And the angle could possibly change. And the points may not be, not every point would be intersected through a line. Good, good. Again, I want you to see what you expect. And so looking at what a perfect correlation looks like is important because the output's expected and it's easy to interpret. It's hard when you don't have a perfect one because then you have to figure out how correlated are they. Good. Now, the rest of the exercises I want to just walk you through. And if you've done them, I'll say, hey, share your code, please. So we're on exercise 5. So in this one, we're doing a box plot. Okay, so you might have done it a little bit differently, but I'm doing a box plot of gross sales in millions. and I'm using a function called boxplot. If you wanted to learn more about the boxplot function, you could use, oops, excuse me, you could use the question mark feature. Boxplot. Okay, and then I see that that also comes from the graphics package, and you have some, this is the default kind of method, okay, that you can then customize. So you have, this is your template. You go ahead, if you have a template for a box plot that you get, you can go ahead and kind of paste that in, and then you can start modifying all the parameters. The problem with that means that you have to know what each parameter means. And a lot of times, I find that it's easy to start with understanding first, what kind of data do I bring in for a box plot? And you only bring in an X variable. There's no Y. For box plots, it's a univariate display that we're showing. One vector of data. So here I'm just showing gross sales in millions. So I don't have a Y, I only have an X. And then I have a title, which is the second parameter. And then I decide I don't want a frame plot, right? I don't want a box around it, and I want to kind of, it will color the my range here, my interquartile range here, the 50% of all values fall in here, so that will be fine. If I wanted to add some color, I don't have to. And you notice here it's also great to see the presence of an outlier. What's this dark line here? Does anybody know? Perfect. It's the median. It's not the mean. And what is the median? Does anybody know? Yeah, but literally, what is it for this vector? But what's the number? Well, you could run the median function. It should be around 27.6. Good. It's just important that you know that this is the median, but it's really hard kind of to see where it is. And so if you're using this as a way to explore data, sometimes you'll want to like just check out what that exact number is, okay? And if you wanted to get the max value, if you wanted to see what this was, you know it's around 250, what function would you use there? Max, right. And I'm doing this in the console window more because I'm using these visualizations to explore my data. So I have the box plot shown there, but I might want to just, I'm trying to interpret it now. Okay, so I'm using R as a tool to help me interpret. So 248. 248 million, right? Great. So that's a basic box plot. If I want to do it horizontal, again, this is just about adding additional parameters, right? Horizontal equals true. That's all we're adding to our basic box plot function. We go ahead and we run that code, and you can see that it might actually be a little bit clearer, okay, to use a horizontal one in this case. The next part C is asking you to do a histogram of for the type of films. That's a weird question. Did anybody get an answer for that? I mean, of course you can see what I wrote, but I'm just kind of curious. What's odd about this question that I'm asking you? Create a histogram for the type of film. It's a non-numeric. So if you went to view movies just to kind of see your data, type of film is genre, right? And so this is where, again, we could start using factor variables to assign a unique number to every unique genre category. And we'll find that there are how many unique genre categories? Does anybody know? 8, correct. Yes. And so we want to create a histogram that shows us on the x-axis 1 through 8, okay, and a frequency count. That's our goal here. I'm going to go back to my code. Apologize, I have a few things open here. I'll walk you through the framework I set up. First, this is the variable of interest. I'm going to convert this to a factor variable, okay? And then I'm just going to create a new column called genre factor, so then I could work with it, and I don't touch really what's happening here. Then, since I know that there's a numeric, so once I do this, I'm just going to do this slowly in the console window. Once I do this, now I can look at the number of levels. I can say levels, and this should give me the number 8. Levels, and I should have 8 levels, right? Action, adventure, black comedy, comedy, drama, horror, romantic comedy, and thriller suspense. This number 7 means that this element is 7, and this one is number 8. That's how we interpret that. Okay, so now that we have that, these levels also have a number associated with them. So that means I can convert or cast this new variable I've created, that's a factor variable, as a numeric, and then graph it. Okay, and then the rest is similar, as you know. You have a title, you have an X label. We don't have a Y label because we're looking at univariate. Right? We're looking at only one variable that we're graphing. And we give it a nice color, and we decide to make the border. Anybody know what color this is? This is hexadecimal for white. Right? Okay. So I'll run this. So the white, the border is that in between the different bins here. So now this is my first genre category, second, third, fourth, fifth, through 8. I might not know at this point what the numbers mean, but I know that it's not equal frequencies for every type of genre. That's all I wanted to know here. And again, I'm using the histogram function to create a histogram that shows me frequency counts for every bin. And the bins have to be numeric, and so I had to convert my genre variable to a factor variable and then convert it again to a numeric. Oh, okay. Ollie, you have to do that with a bar chart probably, or what we're going to do is use a prop table. So I'm going to show you that in a second. But let's just keep this for now. Ollie, I have a good example to show you how to do that. So, Robert, you only see 7 columns where? Okay, so what we're going to do here is we are going to create another histogram that's just a simpler one where we're just looking at gross sales. Again, we just use the hist function. We can add a main, an X label, change the color and the border. We do that, we see that we have bin sizes or bins. Each bar is a bin. This is 0 through 49. This is 50 through 99. And then these are all the values that exist in between this range and the number of them that exist between that range. Histograms are funny, Robert. I didn't specify my bin size, so it just chose 7 instead of 8. That's why. See here, I didn't choose a bin size. Why did it pick 0 to 250? Okay, so you can actually use a parameter. So 2 are grouped together, correct? Which 2? We have to revisualize it and change our breaks. So E gives us, I'm asking you to use the number of breaks, set it to 10. That means the number of bins we're going to have. Here we have 1, 2, 3, 4, 5 bins. I'm suggesting that we do 10. Same data. Let's look. 1, 2, 3, 4, 5, 6, 7, 8, and then 9, 10 is probably in between here. Now, it's not, because you asked R to create 1,000 bins or 10 bins or 5, doesn't mean it's always going to do that. Okay? So it will pick a reasonable number of bins based on the number of breaks you suggest. You can think about what the breaks as a suggestion that you're making to R, but it may not always follow that. Again, we're talking about frequencies and histograms, not bar charts right now. So if you do this again with tickets sold and then change the number of breaks. So I'm using the histogram again. Tickets sold in millions, and I have all my information here, and I'm going to change the number of breaks. So I'll run this code. So this is with 15 breaks, and this is with no setting. So this is saying 15 breaks. There's actually not 15 breaks here visually shown. The data isn't dense enough. We only have 50 observations. So to keep 15 breaks, there's no way to kind of assign those. So I don't know if that makes sense in terms of the breaks. Okay, now we're going to create a histogram with a frequency count on top of the bars. And we do that by just adding one more parameter to a histogram function called labels equals true. If you see it gets cut off like mine did, use this little button here in your R Markdown document, show in new window, and it will be bigger and it'll be much more readable. Now this is getting back to a question that came up earlier on line 147. So if we want to show genre and not show it in the histogram format, we really want to use a bar plot or what's called a bar chart. Most common type of chart, right? So on the x-axis, we want the genre name, comedy, horror, etc. All 8 of them. But to do that, a good way to do that is to first create a table and then use the prop table function, and we can get a percentage. Because my question isn't just like I want counts of how many genre movies or whatever genre horror movies exist in my data set out of the top 50 grossing films, for example, but I want to know what proportion are horror versus comedy. That's just a different way to kind of look at it. So I can use this proportion table, and I need to just convert, it's like casting my genre variable to a table. So let me just show you that real quick. So that looks much better. I get my proportions here. We can see that the highest proportion is drama. But I can't read everything on the x-axis, right? Not every bar seems to be labeled. And then when I make this bigger, still not every bar is labeled. Until I make it really big. Okay, so that's to make that's like if you want to make sure that they're all labeled, just make sure you view it in that format. Okay, now I could also set like figure size here if you wanted to in this up here, but we won't get into that. Okay, so I have my proportion table as well. If I didn't like all the labels that were used, I could actually change those x-axis labels. So here's the basic code for creating my bar plot. All right, and I'm passing in this table of data. I change my font size using this parameter, cex.names. And then I use another parameter called names.arg. So the names for the x-axis are going to be these 8 parameters I'm passing in. And then again, I could change the color in the border. And so I say I want to use, and you notice I'm using the word like rom-com as my output. And I have the font very small. That's another way to kind of work if you need to change the font size, if you have a lot of data and you want to label it. I wanted to just show you that. That all these things are possible to modify. Somebody, when I asked about a scatter plot, used a function called scatter plot. And that comes from a library called car. So I just wanted to kind of show quickly that there are other ways to make a scatter plot. I'm kind of directing us down a path to start using ggplot to create our scatter plots. But I did want to show this one since somebody did bring it up. So it's just using the function from the car library, and that's not to be confused with the cars, plural, data set that's already automatically installed in R. And everything's pretty much the same. Okay, and so I'm getting my, and I'm showing you the X and the Y are down here, and I put my labels here. So these are my labels, actually. And I'm showing you this also that doesn't really matter what order you put your parameters in a function. So this is and with this type of scatter plot, you also get box plots associated with it. So it's good for analysis. Okay. All right. So I would like to move on to showing you some fun stuff with ggplot. And I just want to get my screen ready to kind of show you a little bit. Okay. We're going to work with the movies data set. But if you haven't already, and sure, ask them. And if I could, I'll try to answer them if I can. So we talked about the plot function, and I said, okay, well, we're using that as a building block. And now we're going to begin to use, for graphing, as we get more sophisticated, the functions for a variety of chart types, like line charts, bar charts, even pie charts, density plots, histograms, and many others. We can use the ggplot2 library. So how we do that is, I'm looking at line 176 here. We're going to, if you remember from the PowerPoint briefly, I don't expect you have that, how the exact function memorized at all, but we first write out ggplot. And then that's our first function. We pass in our data, which in this case is going to be our tibble or our data frame. So I called mine movies. The whole thing, okay, is going to be referenced here. And then we use this AES parameter. We pass in our X variable and our Y variable. That should be, at this point, I'm just going to space down. At this point, you've started creating your function. Now, look, there's an opening paren, another opening paren, and we need to have 2 closing parentheses here. So it's almost like, it looks like a function within a function. This is the basic template for any time you start building a plot using the ggplot2 library. Then the next step is to choose our chart type using this plus parameter. So we add plus, and then we can choose geom_point. But I'm just going to get rid of that for a second. So think of plus geom. Press the underscore, and here RStudio will show you the variety of chart types you can choose from. A map, a ribbon, a spoke, a text, a violin plot. Okay, you might have heard of some of these. A tufty box plot. And I mean, there are, probably close to 70 or 80, so that you can choose from. We're going to choose one called Geome Point because we want to create a scatter plot. And then only thing that we're going to put a parameter in here is the color and the border. We don't want our plot to have a border around it, and so we're going to set the border to white so it looks like there's no border. And then here's the color. You can choose the color for the points. When I press run, so now I get a very basic ggplot point. And at this point, I'm not expecting to impress you or try to have you move away from using the plot function, right? Because it doesn't look that much better. And I haven't even had customized anything. But the points do look a little bit better. You see that they're filled by default. But we want to get rid of this gray box. And we want to take some time to modify the X and Y labels and do a little bit more formatting. So let me show you how to build on this. Now, let's say that I wanted to have this formatted to look like it came from The Economist, like the magazine, the periodical. What I could do is I could use the ggplot library, of course, but also a library called ggthemes. Same ggplot call. I'm not going to set any color parameters at this point. And I'm going to just remove this code for a second so I could just show you the one piece of it. And then say theme is theme plus theme underscore economist. So everything the same here, except I'm not passing any color parameters in here. And now I've added one more function called a ggplot called theme underscore economist. I press run, and now it looks like it was printed in The Economist as like a blog or something, as a blog chart. And then you can build on this. So I could start by adding something else called labs, which are my labels. So that's another parameter you use to build on, and that means I could this is where you specify all that stuff that takes hours to write, right? Like the title of the chart, a caption that will tell you where the data came from, so that citation. And then you could also give an X and Y label here. I could run that again, and you see how that's changed. So this is just a kind of an introduction to kind of some of the possibilities and keep you motivated to graph in R, that it's possible to make things look beautiful and to customizable, and it's just a matter of learning the building blocks and then just adding to those. So at this point, I'm going to pause for questions. Good. So we have Anne, I see we have your questions. I'm going to save this. And to answer one of your questions, I'm going to bring up a file. And I'll look at the text chat for other questions. So, Anne, to answer one of your questions, it seems like you want to maybe do something that looks like this. Oops, I just had it up. Excuse me. You saw it. Okay, yes. I know, that's all the fun stuff, right? So this is called small multiples. So bring this up. And let's look at the code. So we use this par function. And what this par function is that we have to first pass in the number of rows and columns. So I know you can't see everything, but you saw, I think, quickly, Anne, and this for anybody who's listening in, I see there's still 25 people online. So I got a question of how to create this chart that we're kind of seeing below. So how do we create, be able to plot our charts next to each other, one by, and this is a format that our Tufty coined called small multiples. So I'm looking at a histogram of gold, silver, bronze metals, say for, and how I've organized this is I've created 2 rows and 3 columns. And that's the layout that I want. So you have to know your layout. And then I can use the par mf row function and specify that I want 2 rows and 3 columns. Then the rest is easy. Okay, so it's 1 extra line of code. I know you see a lot of code here, but it's 1 extra line. And then you could also redo it. In this case, I've changed the bin size. I'm just looking and see if I have any. I could do it with just 2 scatter plots. Okay, but it's just, and with this 2 scatter plot example, I have par mf row, 1 row, 2 columns. I know, right? Guessing at the numbers. I think it always takes a second. Are they rows and columns or columns and rows? So think about when you use mf row, that row is always first. That's the way I use to remember it. Great. And you could always manipulate your data about the outlier question. You can find what the outlier in the example we were looking at with the top grossing films was the max value. So you could always remove the max value from your vector. So you can create a separate vector and or subset your data on the condition that, it doesn't equal the max value. So that it'd be like not equal to max movies gross or something. And then you use the subset function with, say, that condition. Then you use that to analyze that vector. That would be like one way you can do it. There's a few ways. Okay, Noah. I am okay with you using pretty much any package that you want to use that we've gone over. So you can certainly do that. I encourage you to use something that would be useful for you. So if you've mastered the graphics package and want to move on to ggplot, that's great. Just write it in your as a comment or something. Great, 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 great. Any other questions? Well, we're at that time. It's 8:05. So I just want to say thanks. It was really great. I really appreciate your participation. I know some people kind of left at the time when this session officially ended, but for the 19 of you online, thank you, and have a great evening. Looking forward to seeing you in New York City in the classroom.